First of all, I'm Steve Wanger. I'm the Director of Marketing for NAND Flash at Samsung Semiconductor. This is Sylvie Kadivar. She's Director of Strategic Marketing for DRAM products. Some of you might be wondering, why is Samsung here? Well, besides the fantastic 3D televisions, which we are giving away in our booth this week, so you all need to make sure you go by and check out the exhibit booth. Besides those and the phones and stuff, we're actually quite large in the semiconductor industry. We've been the number 2 semiconductor company since 2002. If you go further on that, we're basically a memory company. We make DRAM, we make NAND flash, and we make MCPs, which is a combination of these devices. We've been the number 1 memory supplier since 1993. And what we want to show you today is basically why memory and storage matter in a virtualized environment. What we know is today, the internet itself, the data centers, they're growing and growing and growing. There is so much data out there that needs to be managed. And it's kind of, how big is that? So I have a trivia question for you guys. And there's a prize to be won here. What is the highest defined unit of measurement on a metric prefix system? I'm going to show you the highest beyond petabyte. Does anybody know? Can anybody name anything? Exabyte is next. That is correct. Does anybody have an answer beyond exabyte? Right now, we have a zettabyte. That is correct. We do have zettabyte. We have our first zettabyte here. Does anybody have an answer beyond that? Yes. That is correct. And for knowing that, a 256 gigabyte SSD to the winner. Congratulations. So, if you think about how large a yottabyte is, the combined space of hard drives in the world today does not amount to a yottabyte. Or a yottabyte, I believe is the actual pronunciation. The internet contains 500 exabytes. So we were wondering what comes next. We were just kind of chatting in our office about that. Could it be a Googabyte? Could it be a Jedibyte? Maybe a Wazabyte? How about Hellabyte? This is actually something that's real. You could basically go to Facebook today and look up the Hella page where there's 63,000 fans today. This is a student at UC Davis who's pushing for Hella to be the next metric unit. It's actually going to be going through to the International Committee in Paris, where they say he has his chances of getting this approved are hella slim. So at this point, I'm going to turn this over to Sylvie, and she's going to go through our agenda and what will be presented today.
So good afternoon, everyone. I'm going to give you a brief recap of some of the trends that we're seeing, and primarily because a lot of these trends have implications in terms of the technologies that we offer in the IT industry. So what is the impact on the DDR3 and how Samsung responds to these impacts, as well as the impact on the solid-state drive? And then we'll take it a step further. What are the implications of these optimizations that we're doing in a virtualized environment? And then last but not least, you're going to see today and in the days to come a number of exhibitors that basically are using what we call the green memory technology. So we're pretty much living in a connected world, and you're all aware that even the usage models that we have today are reflected entirely in the internet space, whether it's games, whether it's social media, whether it's diagnostic, and so forth. And so this cloud computing and seamless connectivity are gaining a huge momentum. And at the center of this, you're going to see that memory technology is actually not only present in the client side, but also in the enterprise side. And when you're choosing the right technology, you're going to make a big difference. So we already went through a lot of hellabytes here, but this is also showing to you that when we look in terms of annual growth rate, and this is a slide that Cisco has presented in the past, there's about 40% annual growth rate in the years to come. And we're talking in terms of petabytes per month, which are just astronomical. So another angle, as I mentioned earlier, is the client space is just exploding. And with that, you're also seeing that a whole slew of new infrastructure needs to be developed to support this explosion of the mobile internet in the next decade to come. And that, of course, means that the back-end structure, such as cloud computing and virtualization, is going to have to be optimized. We're going to show to you that it also implies pretty much scaling per square foot. And that means maximizing your density, your speed, as well as optimizing your power consumption. Just to give you an example also of the explosion of social media, not sure if you've seen this before, but we're talking today in 2010 that Facebook ranks among the #2 internet site with over 500 million users, and there is talk of projections of about 1 billion users in the year to come. And in terms of usage, daily usage, it's about 200 million unit users. So I'm just curious, how many of you don't have a Facebook account? Okay. But it looks like there's also a big percentage that does, which reflects also what's happening in the industry and in the era that we're living. And most of all, if you look at also the content that's being delivered, we're talking about 3 billion units of photos per month that are posted on these sites. A growing number of videos, and as the technology is going to mature and enable it, we're going to also see an explosion of the video content. And obviously, mobility has played a central role in this, and the mobile access has been also a great enabler of the social media with over 150 million users. In average, they say that pretty much everyone who is now buying a new smartphone has a high chance of also having a Facebook account. But also, when we look at the implications of these new architectures, there's also a few dilemmas. The first dilemma is obviously power, and this is still a growing concern. In fact, when we look at it, whether it's from Energy Star, whether it's from the EPA, or whether we're looking at it also in terms of polls that have been taken, energy efficiency is still a critical mass. And in fact, depending on how you look at it, sometimes it's also translated in terms of carbon footprint. But pretty much, if you look also at the leaders in the industry, in the enterprise space, when you're optimizing your energy efficiency, you're automatically also optimizing your CO2 footprint. And why is CO2 footprint critical? Well, a study from McKinsey has basically said that if you look at the amount of coal plants that are required to fuel pretty much the data centers of today, because of the power demand that they have, it's ranked among the top 4 pollutants in the industry. And that's pretty phenomenal when you look at the other industries, or the steel industry, the shipyards, and the airlines. So the key challenge is, how do we increase the bandwidth and reduce power? These are two opposing forces in many situations. And the opposing force is also costly. For every watt of data center power, in average, we're also talking about 2.5 watts of power that is needed to cool it. If we translate that into dollars, just looking at it from an order of magnitude, in 2009, the total server revenue, meaning the amount of servers which were purchased, was about $43 billion. Well, if you look at the amount of money that was spent that same year to bring energy and power into the server space, knowing that in average there's about 32 million unit servers worldwide, we're talking about $32 billion of energy cost. And the energy costs, if you look at it based on the types and families of data centers or enterprise sizes, you're seeing that enterprise class data centers are taking a big percentage. But all in all, it is a critical mass. So what does this really mean for us, and how did we approach it when we looked at the overall dynamics? Well, one of the things is, if you look at it in the enterprise, whether it's a large data center or a smaller scale enterprise space, you pretty much have 4 areas that you have to optimize. Whether it's your hardware, your immediate hardware, which is the server, whether it's the rack, whether it's the room in which you're cabling and also cooling the infrastructure, or whether it's the service and the maintenance and the engineering, but also the co-location and hosting of content. Well, we're going to show to you in the next slides actually how, by optimizing the speed, the performance, and the density and the power, how we're able to go for each of these items and optimize it at different levels, meaning the ramification of the improvements is actually seen not only at the hardware level, but across the whole scale. And so let's take a first step at something that we often hear: we need to put more memory in our systems. When you look at the servers that were built prior to the launch of Intel's, for example, Westmere, or AMD's Opteron technologies, well, pretty much you're in an environment of legacy equipment that has been using either FB DIMMs, fully buffered DIMMs, or even much older technologies. When you look at the amount of power consumption that this technology has in the system, we're looking at, in average, if you're even looking at a 48 gigabyte system, the contribution of power in the system is about 26%, as opposed to 20% for the CPU. Now, if you put it in retrospect that the amount of density in the servers is going to grow in the years to come, regardless of the category, that is a critical mass that needs to be optimized. And so the technology today that is being more and more adopted is actually the DDR3 technology. And we're going to show to you how Samsung has been doing optimizations in the DDR3 space. Well, this is just to show to you what we showed to you earlier on, is that even alone, if you take the predecessor FB DIMM technology and you look at what Samsung offers in terms of their DRAM, we're able to achieve about 86% power saving at DIMM level. In this particular comparison, we've compared the power consumption for about a 48 gigabyte of memory. Well, if you use older technology, such as the DDR2, it consumes about 102 watts. If you use Samsung's latest technologies, you can go as low as 14 watts. If you look at some of the enterprise equipments that a number of our partners are showcasing actually at this event, a number of them are already using in full manufacturing what we call the Green Solution 1, which is our Green DDR3, a 40 nanometer based process technology running at about 2 gigabit density and also 1.35. So there, we're at about 28 watts for 48 gigabytes. Now, how does that translate in terms when you put it in a system? Well, when we did the comparison, and these are actual measurements, the 86% saving that you're getting at the DIMM level is translated into 44% at the system level. In this particular measurement case, we took about 8 hours active and 16 hours idle, and we compared basically both systems and look at the ultimate contribution of the memory's impact. When you now look at it, even scale it up, and look at if all the servers in the US alone, about 11.5 million unit servers, if they were replaced today by the latest technologies that use that particular memory, you're talking about an average of 34 terawatt hour of power consumption that's saved, or over $2 billion of revenue that can be used for something else. Let's look at it now from another angle. If you look at the saving that's happening between a previous system and a new system using the Samsung technology, and you look at a rack configuration, for example, well, 5 servers in one rack that is, for example, has about 2,000 watts of power associated to it. Well, replacing those servers with a new server using the optimal technology, you're also increasing the footprint of server per rack. In this particular case, 4 more servers. If you look at it also from the overhead costs on the IT space, looking at the floor space, the cooling, and the facility power per rack, we're also noticing that in about 1,000 server entity, you're actually saving about 44% because you're eliminating also the number of racks. So there's 2 ways of also looking at this saving. Another angle of looking at this saving is the amount of dollars that you save entirely from the power consumption level. Well, the 170 watts is actually about 2.9 megawatts saving per year. And if you translate it into having a whole system that is using these latest technology, you're saving about $194,000 in a 1,000-server configuration. And another way of doing it is looking at it as 3 terawatts saving. Well, that money can be reinvested. There is a bandwidth limitation today in the whole enterprise space, and there's more demand in terms of optimizing the servers. So that amount of money can be reused. And so again, if you look at it now from a much more global basis, since there's still talk about CO2 footprints, and in fact, a number of data centers are going to, in the future, see also that there could possibly be some levels of taxation happening. Could be also at international level. Well, the awareness also is that when we call it actually a green technology, we're also not only saving in terms of dollars, which translates into green money, but we're also translating into an environment that is much more healthy, and in terms of saving the 95 terawatts of power per, when you replace the 32 million unit servers, translates into $6 to $7 billion of saving per year, or 68 million tons of CO2, or eliminating the need for 18 power plants, or eliminating 13 million cars off the highway per year. And so now I'm going to pass it to Steve, who's going to talk to you about the implications for SSD.
Thank you, Sylvie. So what's the deal with SSDs? They have low power. They have incredibly high performance. It's kind of how do you basically expand the data center without expanding the data center? That's really the key topic for SSDs. So if you think about SSDs, you either got capacity-optimized systems, you got performance-optimized systems. SSDs are all about performance-optimized systems. It's not gigabytes per dollar. That is not the correct metric. The metric is IOPS per dollar. That's your speed. IOPS per watt is your power. Gigabytes per watt is your size, your energy. So first, how do we get to these great speeds with our SSDs today? It starts with the NAND flash. So at Samsung, we're the world leader in NAND flash. We have been for a decade now. NAND flash historically had been SLC, a single-level cell, moving to MLC, 2 bits per cell. It's now moved to what we call toggle mode, which is a DDR mode. With that happening, we're able to greatly improve the IOPS in these drives. So what's going to happen is you're going to keep getting faster and faster solid-state drives. Other aspects of this is we're going to be going from a 3.3 volt to a 1.8 volt in the future. So all these things together allow for much, much better performance in the SSD and great, great reliability to go along with it. If you compare it to a 15K RPM SAS drive, the SSD itself completely outperforms it. And just IOPS straight up, 68 times better in IOPS. So you're talking about as much as if it's 100% read, 25,000 IOPS versus 350. But a typical environment, 70 read, 30 write, it's still 15,000 IOPS. That's just tremendous speed. If you look at the power, SSDs have no moving parts. There's no mechanical operation. Mechanical operation is almost 4 watts of power. So if you just take that out off the bat, it's a third less power. So when you combine these two features, you could get as much as 250 times better IOPS per watt. This is a tremendous, tremendous benefit for you as far as the speed and the performance of the SSDs. And later on in our slides, we're going to be showing you what we have in demoing today that you can see tonight, which is how this actually helps in a virtualized environment. So again, if you compare these things, just on a typical 70 to 30 read-to-write ratio, the SSD cannot be touched as far as performance, and it's all about performance. Again, it's not about dollars per gigabyte when you're talking about SSDs. That's if you're just talking about storage only. Why am I not? Oh, there we go. Sorry. So in conclusion, on the memory side, both the green SSD, the green DDR3, it basically lowers your total cost of ownership. That's really the key here. You're going to have lower voltages across the board. On the SSD front, you could replace multiple hard drives. On the DRAM side, much lower cooling costs. You also get that on the SSD as well. You could get higher densities with less components. It's less real estate. Or you could keep the same real estate and get that many more servers, that many more racks in place, which helps you expand the data center. So I'm going to turn it back over to Sylvie to talk about virtualization.
So one of the things that we obviously hear, and you're all very familiar with it, is number of physical servers is kind of being fixed, and the number of logical servers is increasing through the virtualization. And one of the things that we've noticed very often is when we're talking to our customers or we're also interacting with the end users is everyone's saying we need more memory. But when we go into the details of, well, have you looked into the differences between the different memories that you're using? Did you know what the implications of it is on virtualization and power saving? Then suddenly it's silent, because so far everyone has looked at memory as, okay, just put it in. Well, it is going to make a difference when you're looking at high density, and it is going to make a difference when you're looking at scaling up a system per square foot. And so in this particular case, we looked at a scenario of a 2-socket Westmere-based platform with the assumption that the servers were running about 40 virtual machines. The other assumption that we made was that there's about 3 gigabytes per virtual machine, and also 1 gigabyte dedicated to vSphere. All of them obviously are 18 DIMM slot, 3 DIMM per channel configurations. Well, looking at, for example, what you have today, in some cases, if you're looking at just the very basic DDR3 industry standard, that pretty much from a lot of the vendors are either in a 50 nanometer class or what they call 60 nanometer class. These are processes that are of a larger geometry than what Samsung offers. And actually what we notice is, well, first of all, if you were to run 40 virtual machines, you can't do it if you're using DIMMs, a 4 gigabyte DIMM that is using 1 gigabit base component. And if you start looking at the more details in terms of the type of memory you're using, whether it's the Samsung 2 gigabit base, so these are 2 gigabit components that are being used in an 8 gigabyte DIMM, and if you're using our 40 nano class or even our most recent, our 30 nanometer class, well, you see that the usage models are phenomenal. Minimum capacity can go from 144 gigabytes up to 192 gigabytes. That translates itself that you're able to address 42 virtual machines or up to 56 virtual machines. And then if you look at it from a maximum capacity, it means that if you're using a 8 gigabyte configuration, you're pretty much, without having, let's say, additional expansions, you're maxing out in terms of memory to about 144. But if you take a closer look in terms of the technology you're using, such as a 16 gigabyte or even 32 gigabyte using some of our more recent solutions, you can go as high as 384 gigabytes of density, translating into 113 virtual machines. So on the virtual side, you can do a lot by making a smart choice in terms of your DIMM, and as a result, in terms of the capacity. But what does it mean also in terms of the power? So the first thing is, if you look at using 4 gigabyte RDIMMs, using kind of the basic that is out there that may be in some ways more cost effective, but it's also limiting your system's capability, you're seeing that you can't guarantee the 40 virtual machines. You're limited to 72 gigabytes. But if you took that as your basis in terms of power consumption, and you looked at, by replacing it now with some of the Samsung solutions that we have to offer, you're not only enabling higher levels of virtualization, but at the same time, you're reducing the power consumption. So you're enabling a higher level of virtualization, and your system is consuming less power. And that's pretty phenomenal, because we're showing here that we can enable 18% up to 43% of power saving. And a similar exercise can be done also with an AMD-based processor. And you can see here that because of the difference in the configurations of that level, that CPU, the level of capacity, maximum capacity and minimum capacity changes, but the story remains the same. is that if you are using Samsung's latest solutions, for example, an 8 gigabyte today in a 40 nanometer class, not only you're enabling higher levels of virtualization, but you're also guaranteeing a lower power system. So now I'm going to hand it to Steve, who's going to talk more about how SSD and virtualization are going to also show you something.
Thank you. So this was an exercise that we worked with HP on. They put together 2 identical machines, in which we actually have in our booth this week, so you can come and see this live happening, where they did basically an SQL server, and they put in an absolute identical. One machine has 8 of our SSDs. The other machine has 8 15K SAS drives. This is what happens with the IOPS with the hard drives. You could see it's maximizing maybe around 500 IOPS doing this test, an 8K byte random read test. This is the SSDs. The guys at HP were blown away by this when they did the testing. So basically what ends up happening is after a queue depth of 2, the hard drive basically fails. It just can't work anymore. It'll basically, because of its latency, it just runs out of bandwidth to perform. Where the SSD at a queue depth of 32 basically plateaus, so you're looking at almost 8,000 IOPS still maintaining at a queue depth of 32. They didn't test beyond that, but the estimations were that it was still going to maintain pretty good IOPS power there. If you look at this, so going back to our dollars per IOP or IOPS per dollar, just looking at the book cost that was on HP's website, if you did a configure to order type deal, this is about 2,000 times better IOPS per dollar than a similar HDD system. So it's unbelievable performance. If you look at this just in latency, if you look at this graph on the side, you're going to see this is a logarithmic scale. So this goes up to 2,000 milliseconds. The hard drive, again, it just, after a queue depth of 2, it can't handle it. Now you start talking about getting up to 1,000 milliseconds latency. The solid-state drive maintains, the latency at 32 queue depths is better than the latency of a hard drive, basically, or the same at a queue depth of 1. So again, it shows you in a virtualized system, when you're talking about performance, you need to be able to perform because you've got a lot of commands coming into these virtualized systems. Solid-state drives provide so much better performance than you could ever get with a hard drive. So yes, they cost more up front, but what you're getting for that cost is tremendous to just your entire system. Now, I'm going to turn it back to Sylvia to close out.
So pretty much, if you look back in terms of what we've shown you, is the implication of those savings have been present in terms of the hardware, in terms of the rack level, in terms of the optimization of the room, particularly the kilowatt per square footage, and also the equipment, and also the service. The reliability, the quality also of the technology does make a difference, and overall then reduces not only your CO2 level, but also your overall total cost of ownership. And so we have here a few examples of where this technology is being used. This is just a very small number of systems that our partners are using this technology. I strongly invite you to go to their booths too. And they are using the latest technology from Samsung, both for the DDR3 and the solid-state drive. And in fact, HP, a few months ago, when they were doing the metrics and they were doing the measurements on their system, they were comparing a G5 ProLine system with their latest generation 7. And they concluded that not only they were able to decrease the total power of the system by 58%, but they were able to increase the total memory capacity by about 200%. IBM also at their booth is going to be showing some of their blade servers with the latest Samsung technology. There you're going to see 16 gigabyte VLP systems, so these are very thin, low-profile DIMMs. And they're also going to be showing a few demos and also showing to you that they're enabling more virtualization with a higher level of memory in terms of their systems. And you can see here, again, the trend for them is going up the scale in terms of memory. And there, again, choosing the right memory does make a huge difference. And Cisco, with their UCS system, has been also a key partner from us, and they are also exhibiting a variety of UCS systems that are fully supported by the Samsung technology, the Samsung Green Memory technology. And again here, they've taken a stance of providing you actually even extensions with this green memory solution. So not only you get an optimal power configuration, but you're also getting a maximization of the memory for a virtual environment. So what we'd like you to remember, because there's a lot of material here, is with memory, we're able to guarantee you, with the DDR3 technology, overall more bandwidth compared to its previous generation. But particularly when you look at it from a memory power, the footprint can be reduced by choosing the right solution by about 84%. And it is translated to, from our measurements, to 43%. From our customers, they're even talking about 50% to above. And it's choosing higher density, obviously, is going to enable you to develop higher density systems with more capacity, but at the same time it means more possibilities of creating larger virtual machines per system. You can run up to about 300 virtual machines or up to 150 mirrored virtual machines, depending on the technology that you use from Samsung. And again, when you look at SSD, as Steve mentioned, 41 times faster than the traditional hard drive, and definitely a very good solution as we're entering the space of a lot of cloud computing and virtualization and reducing the latency in the virtualized environment. There's more information that you can find from our technology, but also our partners on our website. I invite you to go to the samsung.com/greenmemory, and there you will see actually some videos and also tutorials that give you a better insight in terms of why it makes a difference to use Samsung technology. Thank you very much. And again, I think what speaks for itself is our customers, and also, as I mentioned, some of the data that we've shown to you, hearing it from the data centers and hearing it from our OEMs, they're actually very surprised at how memory itself and storage can make a huge difference. In the past, we've concentrated only on the CPU, and we strongly invite you to learn more about these technologies and see how it can help you in optimizing your system. Thank you very much.